So we will take few more examples again, right? For example, we will take K3 CO oxalate ion, right? Thrice, right? Each oxalate ion is having -2 charge, right? Oxalate ion, you know, CO minus CO, oxalic acid, oxalate ion, right? This is, so this is having -2 charge each. How many -2 charge systems are there? 3 ligands are there. That means total charge of the ligand is -6, right? -6. You have a +3 counter ion. That means charge on the complex is -3. To have a -3 charge, cobalt should be having +3 because this is -6. So +3 -6 -3 -3 is counteracted by our 3 potassium ion. So how do you name this? Someone asks you. Very simple, student. Start from this end. Potassium, right? Go for naming the central complex ion. In the complex ion, ligand has to be named. How many ligands we have? We have 3 ligands are there. 3 bidentate ligands are there, but it doesn't have the name di, tri and all. So we don't have to use bis, tris and all. So this is how many oxalate ions are there? 3 oxalate ions are there. Oxalate, that is what has to be named? E has to be replaced by ATE, has to be replaced by O. That is potassium trioxalato, potassium trioxalato, cobalt, take care, it is not cobalt, it is cobaltate, right? Cobaltate. How many oxidation state? 3. That is potassium trioxalato cobaltate 3. Because it's an anionic complex, you need to have a end by the word ATE with an oxidation state. Potassium trioxalato cobaltate 3. Very clear? Very simple one. I'll take for example copper, ethylene diamine, I'll take it, sulfate. This is again a positively charged complex. That is cationic complex. How do you name this? So you start from the complex ion. In the complex ligand is ethylene diamine. Ethylene diamine, it is also already having ethylene diamine. Already it is having di-tri and all. Right? In that case, you need to use number of ligands will be spoken by, not di-tri, etc. It is, you know, the bis, tris, tetrakis, etc. Right? So that is why, how do you name this, students? That is ethylene diamine is bis, right? Bis bracket you write it, ethylene diamine, bis ethylene diamine, right? Copper, keep it as copper itself. Why? Because it is a positively charged complex. Copper 2, because it is a neutral ligand, +2 is the oxidation state, +2 is the charge, +2 is the oxidation state. Copper 2 sulfate at the end. Very simple, copper 2 sulfate at the end. This is the name of this particular complex, name of this particular complex. Very clear? Yes, we have done with the naming of this. Few more examples again we will take it. Quickly we will rush through the few more examples. K2, for example, K2, Cr, Cn, ammonia, Cn 4 times, ammonia thrice, right? Kr, for example, we will put it as 2, right? K2, Cr, Cn twice, ammonia thrice, NO. Or you can keep this 4, this ammonia as such you can keep it, right? Because it's a octahedral complex having 6 ligands, right? Cr, Cn 4 times, ammonia, we have NO. How do you name this? Go ahead. So start from the left to right, because it is a anionic complex, right? Charge of the complex is -2. So charge should be -2, means the chromium should have a +2 charge, student, because you have a Cn -4 +2. All these are neutral ligand. NO is neutral and ammonia is a neutral ligand. How do you go ahead with this? Potassium, 1 by 1, cyano, amino, nitrosyl. This is NO is nitrosyl. Cyano, amino, nitrosyl. That means amino has to come first. Potassium, amino, right? Tetracyano, potassium amino, tetracyano, nitrosyl, chromium, not chromium, chromate, right? It is chromate. Because you have to end by the word eta, because it's a negatively charged complex. Potassium amino, tetracyano, nitrosyl, chromate 2, oxidation state 2. This is the name of the complex, very interesting. Potassium amino, tetracyano, nitrosyl, chromate 2. Not a difficult, easy only, just go through it. So for example, we have Cr, water 4 times, Cl2Cl. This complex, how do you name it? Very quickly, cationic complex, because counter ion is negative. Naming, this is aqua, tetraaqua, right? Tetraaqua, because we have 4 water molecule. Tetraaqua dichloro, chromium, keep it as such, chromium, right? Chromium. What is oxidation state? 2 chlorine here, 1 chlorine here. Together, this oxidation, this charge of the complex will be +1, that is why we have a -1. To have a +1 here, oxidation state should be +3. Otherwise, -2 here, +3. That means oxidation state of the chromium is +3. Keep it in bracket 3. Tetraaqua dichlorochromium 3. Right, clear? Last example we will take it, students. A little complicated one. Platinum. This portion, Cl2, right, 1. It's a complex. Together we are writing PtCl4. This is the complex. See, when the complex is like this, we will study these kinds of complex. What is called as coordination isomerism it is. Right, in the isomerism we will go through this complex. It has 2 parts. This is a cationic part. This is a cationic part, that is in the complex, coordination isomerism it is. In the complex itself, entire complex, this is a, the containing 2 complex ion. Both are complex ion, but this is a cationic part of the complex ion. This is the anionic part, because anionic part will always be put it in the right side. So you need to name these 2 separately, that's it. But since it is an anionic complex, when you name platinum, you have to put it as platinate here. Since it is a cationic complex, you have to keep it as platinum itself. Right? You need to name separately. Start from here, go till here. Since it is an anionic part, right side it is. That is why it has to be named as platinate. This has to be named as platinum itself. So quickly can we name? That is tetramino dichloro, platinum. What is oxidation state? Oxidation state is 4 here, Cl2, right? I'll put it across like this. Cl minus, this is Cl minus, right? This is the neutralization which has happened here, PtCl2, right? That is PtCl2, oxidation state will be left out, positive charge will be left out, +2 will be left out. This is counteracted by the -2, clear? Counteracted by the -2 which is present here, right? So this is +2 means we need to have an oxidation state for the platinum here, 4. That is tetramino dichloroplatinum 4 and tetramino dichloroplatinum 4, and this has to be the +2 oxidation state, tetramino dichloroplatinum 2 and tetrachloroplatinate 2. And repeat, tetramino dichloroplatinum 4, tetrachloroplatinate 2. This indicates this is the positive negative charged part, anionic part, this is the cationic part. So you start from left to right. So name this first, then go for naming this and put it as ATA in the case of the anionic complex. So this is about the IUPAC nomenclature. In the question and answer session, we will take few more examples and we will try to clarify if at all not cleared. So it's very easy, students, not a very difficult thing. So certain rules has to be followed. Start from left to right, then go for the right to left. Then what you do is you check the ligand naming. IDE has to be replaced by, you know, the O, whereas ITE or ATE has to be replaced by, E has to be replaced by O. Then you have a ligand. In the case of the complex, cationic complex, central metal ion, you keep it as such. Anionic complex, ATE word introduced. Always make sure that you will be writing oxidation state in front of the metal ion. Those things has to be kept in mind. Apart from that, it is, you know, the no other rules are there. You can make use of these rules and you can name the coordination complex by using IUPAC nomenclature.